I have some bad news about paired t-tests. So we went through the example of pre and post tests and looking to see whether the change in something like happiness level could be measured using a paired t-test to see if it's statistically significant. In this set of slides, we're going to talk about the idea that a paired t-test is really just a one sample t-test using the differences. And I'll say that again, a paired t-test is just a one sample t-test using the paired mean differences. I love punctuation. I rarely use exclamation points. So this is just for a little bit of emphasis. Here's some really cool data, some older data on the labor force participation by women. And these are data that measured the change from 1968 to 1972, which was a time of big social upheaval in the US and introduced a lot of women into the workforce. Now, this is a number, it's called the LFPR, that quantifies, we can say it's a continuous variable, and it measures how economically active part of the population is. So a research question, again, question ends with a question mark, and a nice little word like did, or does, or is, or are to begin with. Now, we can ask, did women's participation in the workforce increase over this time? And the way these data were collected, because you have to ask about the design of the study, is in a bunch of different cities, this variable, the LFPR, the labor force participation, was measured for the women in those cities. And we can see that from 1968 to 1972 in New York City, it went up. In LA, Chicago, Philly, stayed the same. Detroit, it went up. And we can ask, did the average of 1968 differ from the average of 1972? Now, you might be tempted to say, okay, well, I have this little cheat sheet here, this little choose the statistical test sort of decision flow chart. And it says, if I have a binary variable that defines my two groups, and if I have some variable that I can calculate the mean for, what I do is just take the mean of one and the mean of other, and I see with an independent samples t-test if the mean went up over time. But you know a little bit about the design of the study. You do not want to link the information from New York with the information from Houston. It doesn't make sense. The New York data has to be paired with the New York data. And so this is a great question for the paired t-test. Now I'm going to show you, however, that the paired t-test is basically a one sample t-test. So here is how we run the paired t-test in Stata. We say t-test, and then we have the variable 1972, the variable 1968. And remember, those two columns are New York 6872, Philly 6872. And here you see the mean. Now remember, that number is the difference in the means. I hate saying this. It's the difference in the means, but it's also the mean of the differences. So if I went for each city and calculated the differences, that would be the average of all those differences. If nothing were going on, what would you expect to see as the mean of those differences? Well, some cities would go up 2, 3, 4 points. Some cities would go down 2, 3, 4 points. They'd all sort of cancel each other out, and you get something around 0. But here we get some sort of signal. It's not 0. It's small. It's 3 percentage points on the scale, but it's not 0. And in fact, if you take that not 0 and put a confidence interval around that, you see it doesn't include the null value. So the p-value must be statistically significant at the 0.05 level. And we can say we're 95% confident that on the average, this labor force participation rate increased. Here's our 0.49. Here's our 6.24. Our best guess is 3.3. And if you want to put a p-value on it, you can say this. So this is a nice summary of a paired sample t-test. And I'll show you how we can write this exact same summary using only the one sample t-test. So the one sample t-test, remember, it's one sample. It's one column of data. And the way we can do this is we can calculate the difference for each city. And remember that in a one sample t-test, we get to choose the null hypothesis. Here, our null hypothesis will be there's no difference. They all kind of stayed the same. Some went up, some went down. 2, 3, 4 up, 2, 3, 4 down, on the average is 0. That was the mean difference. The paired t-test we just saw looked at the difference in the means. So I want you to look at these two equations. In the paired t-test, we look at the difference in the means, and we take the standard deviation of the differences. That's the exact same thing that we did in a one sample t-test, right? If we take the difference and calculate all those differences and then take the average of them, well, that's the average of the differences. And then for that column, it's the standard deviation. It looks like this. Now, remember, these data are not independent of each other. In each row, they're paired somehow, and we can make a new variable that does, sorry, I'm not good with this circling. We can do a new variable that calculates the difference. So here's the difference between these 2 years. And those differences are New York minus New York, LA minus LA, Chicago minus, and so on. Now take a look at this column. If nothing changed between these 2 years, what would you expect to see in this column? Well, you could eyeball it, and you would expect to see roughly an equal number of positive signs and negative signs. Roughly the same number that would go up would go down. And we're going to do that eyeballing. This is a little teaser for when we do non-parametric tests at the end of the semester. But for now, we can say, all right, let's just take that column and calculate the average. If the average is 0, then on the average, no one changed. And we can run that as a one sample t-test. Here's my new variable, and let me run that one sample t-test right here. This line of code that I just obfuscated says generate diff. Generate is the Stata word for make a new variable. Diff is this new variable that I'm making, which is simply the 1972 column minus the 1968 column. And when I calculate those differences and then take the mean of the differences, it's the same as the difference in the means. Confidence interval, same. P-value, same. And that's why we said a paired samples t-test is a one sample t-test on the differences. Oh, I forgot. Let me add one more thing to the title of this slide. I'll add 3 exclamation points. Hopefully that'll help you understand the mechanics of the paired samples t-test.